3.45, and we'll divide that by 2.3. So the first thing we look is we say, well, on the outside we have a decimal here. We don't want that, so we'll move one position to the right. And if we do it here, we must also move the inner number one position to the right also. So then we have a new problem that's similar, but we will then be solving this new problem. And the problem will be 34.5, and we'll divide that by, again, the decimal has moved, so it's 23 on the outside. So we still have a decimal point here, and the decimal in the answer just floats right above that decimal point. And you can put that there in the beginning of the problem. Now we get started. All right, so we say 23 times something is 34. Of course, times 1 is 23. I know that if I go times 2, I'm going to get, something over 40, because 20 times 2 is 40. This is a little bit more than that, so times 2 is already going to not work. So we know that this has to be times 1 for 23, and then we subtract. 4 minus 3 is 1, 3 minus 2 is 1, so we have 11. Now after we subtract, we always grab the next digit we have, in this case a 5, which comes down here. And then we ask ourselves, 23 times something is 115. I don't really know the answer, so I kind of have to guess. It's going to be times 2 or times 3 or times 4 or times 5. I'm not really sure, so just go over to the side and let's check out what is 23 times 5. 3 times 5 is 15, carry the 1. 2 times 5 is 10. One more is 11. It's exactly 115. When you do your work, you might start out with times 3 or times 4. Eventually, you get as close as you can. In this case, we match exactly, so it goes 5 times. And we just said that the answer to that was 115, so we subtract and get 0. Now we get a remainder of 0, and we do not have any other digits to pull down after the subtraction, so we're done. We're done. We're done because we got down to a remainder of 0, and we didn't have any further digits to bring down. So the answer to this problem is 1.5. Just probably put it right here, 1.5, and I'll circle the answer. So what this means is if I have 3.45 of whatever, of candy bar, and I'm dividing it by 2.3, then what that means is this can fit into this one whole time plus another half, because 0.5 is a half. So it can fit one whole time, but it can't fit twice. It can only fit a half more. That's what it means when we get a decimal as an answer in decimal division. All right, let's move along. We're going to tackle problem number 2. Let's say we have the number 3.06, and we're going to divide that by 0.17. Now, on the outside, we have 2 digits after the decimal, so we want to move this 2 positions to the right, which means we have to also move this 2 positions to the right to keep it balanced. So really, we're going to write a related problem, 306, because I moved the decimal over here, divided by 17 after I move the decimal here. This is the problem we're going to now solve. But remember, there's an invisible decimal point here, and so you can just kind of bring it up above. We're going to have an invisible decimal point there as well. All right, now what do we have? 17 times something is 3. That doesn't work. 17 times something is 30. Well, it's only going to be times 1, because we know that times 2, 17 times 2, I just happen to know is 34. If you do times 2, you'll work out to be 34. That's too big. So it has to be times 1, which multiplies to give us 17. All right? Now, you can do the long subtraction. I mean, you can do it any way you want. I guess we could just go over here and say, what is 30 minus 17? And we can borrow, making this a 10, making this a 2. 10 minus 7 is, it's not a 6, it's a 10, is a 3 there, and then this is a 1. So the answer is 13. Or you can just count it on your fingers, whatever you want to do. But the answer that you get, 30 minus 17, is 13. After we subtract, grab the next digit, which is a 6, bring it down. Now we have 136. So 17 times something is 136. How close can we go? I don't really know the answer, so let's just try times 8. 8 times 7 is 56. Carry the 5. 8 times 1 is 8. Then we go 9, 10, 11, 12, 13. 136 exactly. Of course, I know what I need to multiply by. You might guess 6 or times 7. You get closer and closer. Eventually you get times 8 to get the 136. So put an 8 here. 8 times 17, 136. Subtract, get a remainder of 0. All right, now we get a remainder of 0. We could add zeros here, of course, but we don't need to drag anything else down because we already got a remainder of 0. So we have 18 point invisible 0 right here. So you could just say that the answer was 18 to this problem, or you could circle it up here. The answer was 18. So what it means is that 3.06, when we try to look at 0.17 and fit it in there, it happens to go exactly 18 times. Doesn't have any leftover remainder or anything like that. It goes exactly a whole number amount of times. All right, let's take a look at problem number 3. Let's take a look at 1.92, and we'll divide that by 0.08. First thing we do is we look out here and say, all right, we don't want that decimal, so we move it 2 spots that way. Then we must move this 2 spots that way. And so we work and solve a related problem, which is 192 divide by, move the decimal twice, means we just have 8 on the outside. So now we're going to solve this problem. But again, as always, this 192 has an invisible decimal here, and therefore up here has an invisible decimal as well. So how do we continue here? We cannot divide into 1, so we consider 19. 8 times 2 is 16. 8 times 3 is 24. That's too far. So it has to be 8 times 2 for 16. Subtract, and we just get 3. After we subtract, we drag the next digit down, which is a 2, like this. Now we consider 8 times something is 32. 8 times 4 is exactly 32. So we subtract, and we get 0 for our remainder. Now we could put other zeros after the decimal and drag them down, but we don't need to because we already got a remainder of 0. So we stop. We have a remainder of 0, no more digits here. And so the answer that we get for this problem is just 24. The answer is a whole number of 24. All right, so for the last problem, we got a whole number answer of 18. First problem, we had a decimal answer of 1.5. Let's work the next problem and see what we get for this. Let's say we have the problem 16.64, and we'll divide that by 6.4. So again, the first thing we do is we say, well, we have one digit here we don't like, so we move that decimal 1 position. That means we must move the decimal that direction also 1 position. So we're going to solve a related problem, which is going to be 166.4 divided by, this will be 64 after we move the decimal. This is what we then want to solve. Now, again, we have a decimal here, so we just float it right above. That's where the decimal will be in the final answer. Now, 64 can't go into 1. 64 cannot go into 16. 64 can go into 166. I'm not sure how many times, so let's just take 64 times 2. 2 times 4 is 8, and 6 times 2 is 12. So I get 128. I'm very confident that I cannot go 3 times because 128 is already pretty close to 166. You can multiply by 3 if you want, but you'll find out that it's bigger than 166. So it only goes 2 times, and the answer we get was 128. We just calculated that. And now we have to do this subtraction. Now, if we do the subtraction right here, we'll have to borrow, and that'll be ugly. So let's go over here. 166 minus 128. So we have to borrow here, make this a 16 and make this a 5. 16 minus 8, you can go down. 15, 14, 13, 12, 11, 10, 9, 8. And you land on 8. So we have 8 here, and then 5 minus 2 is 3. 1 minus 1 is 0. So when we subtract, we actually get 38. After we subtract, we grab the next digit, bring it down. Now we have to ask ourselves, 64 times something is going to be 384. And I know it has to be much bigger than 2 because that's pretty far away. I don't really know what the answer is, but let's just see 64 times 6. 6 times 4 is 24. 6 times 6 is 36. We go up, 37, 38. 384 exactly. If you don't guess properly the first time, maybe you guess times 5 or times 7, then just get as close as you can. And we find out that 6 is the right answer. We multiply and get 384. Remainder of 0. So we can stop because we have a remainder of 0 and no other digits to drag down. So the answer to this problem is 2.6. And I'll just circle this as the final answer, 2.6. You could write it off to the other side if you'd like. All right. I think we're about to the halfway point. Let's take a look at the problem 45.6, and we'll divide that by 0.3. Same thing. Outside, we want to move the decimal one position, so then we must also move the decimal over there one position. So that means we'll solve the related problem, 456, and we'll divide that by 3 on the outside. Now again, always an invisible decimal point after numbers, so there really is an invisible decimal point there as well. Now what do we have? 3 times what is 4? Well, the closest I can get is 3 times 1 is 3, and subtract, and I get a 1. After I subtract, grab the next digit, which is a 15. 3 times something is 15, has to be 5. 3 times 5 is 15. Subtract, get a 0. Now, you think, oh, I'm going to stop. I have a remainder of 0, but every time I've been telling you, remainder of 0, and you check to see if you have another digit, but I have another digit now, so I'm not really done. I have a 6 right there. I have a 6 right there. So then 3 times something is 6. What can that be? 3 times 2 is 6. Then I subtract, and I get a 0 here. Now I really do have a remainder of 0. I don't have any more digits. I could add zeros, but I don't only add zeros after the decimal if I have to, if I don't have a remainder of 0 here. But since the remainder is 0, there are no more digits, I stop, and I say that the answer to this problem is exactly 152. 152. All right, past the halfway mark. Let's take a look at our next problem. And it is going to be 8.4, and we'll divide that by 1.5. All right, on the outside, we move the decimal 1 position, so that means on the inside, we must also move the decimal 1 position. So then, we're going to work a related problem, 84 divided by 15 after we move the decimal, 15. This is what we're going to concentrate on. And again, don't forget that after this 84 is an invisible decimal, so the decimal in the answer will be right above it. And, we'll just kind of continue on to see what happens. So we have 15 cannot be divided into 8s, too small. So we consider 84. 15 times something is 84. I actually don't quite know, so let's just start multiplying. I'll just guess times 5. 5 times 5 is 25, carry the 2. 5 times 1 is 5, 2 is 7, so I get 75. Okay, 75. I can try times 6 if I want. 6 times 5 is 30. 6 times 1 is 6, 7, 8, 9. I would get 90. 90 is too big, so it can't be times 6. It has to be times 5. And I get 75 as that answer. And subtract. Now, I can go off to the side and borrow, or I can just think about it. 75, I can just count up to 84. Starting from 75, 76, 77, 78, 79, 80, 81, 82, 83, 84. So that's a difference of 9. 84 minus 75 is 9. Now, I've done the subtraction. I look for another digit. I don't see another digit, but I can't really stop because the remainder's not 0. I want to get every one of these problems. The remainder is 0. The remainder is 0. Over here, the remainder, I got down to 0. Here, I have a remainder that's not 0, so I really don't want to stop, but I don't have any more digits here. What do I do? Well, you then, at that point, are allowed to add zeros after the decimal point. 84.0 is exactly the same number as 84. You can put as many zeros after the decimal as you need to or want to. So then, I do now have another digit, which is a 0. Now I have 90. Now look here, 15 times something is 90, but I just did that. It's times 6. So times 6, 15 times 6 is 90. Now I subtract remainder 0, and there's no more digits, so now I got down to a remainder of 0, and this is the final answer. The final answer to this problem is 5.6. That's the answer to the problem, 5.6. A little bit tricky when you have to add these extra zeros, but I think by doing lots and lots of problems is how we conquer that and get past that. Now, in this problem, I'll give you a little bit of a heads up. We had to add a 0 to get the process down to where we wanted to. In this next problem, we're actually going to have to add 2 zeros. I don't want you to stress out about it. We'll just see it unfold as it happens. But I'm giving you that heads up because I want you to pay attention. All right, let's say that we have the problem 1.05, and we'll divide that by 0.28. All right, on the outside, don't like this decimal, so I move it 2 positions, and then I have to do the same thing here, 2 positions. What do I have? 105, I'm going to work a related problem. 105, and I'll divide that by, move it 2 positions, 28. All right, and as always, I guess I'll just kind of make this a little longer because I know I'm going to need it. After every whole number, you have an invisible decimal point, and so that means the decimal point of the answer will also be right above it. Now, question. 25 cannot go into 1. Yes or no? Of course it can't. 28 cannot go into 10. So we have to consider 28 going into 105. I don't actually know what the answer is, so let's try times 3. 8 times 3 is 24. 2 times 3 is 6. 7, 8 is 84. Let's try one more. 28 times 4. 8 times 4 is 32. 2 times 4 is 8. 9, 10, 11. 11 here. So 112. So it cannot go 4 times. That's too big. So it actually has to go only 3 times. 3 goes right here. 3 times 28, we just said, is 84. Now, we can try to do the subtraction here, but we're going to end up having to borrow, so it's just going to be not so great. So let's go over here and do the subtraction over here. So we will say 105 minus 84. 5 minus 4 is 1. Here we'll borrow, making it a 10, and that is a 0. 10 minus 8 is 2. So the answer is 21. All right? So we did the subtraction, we got 21. We look for the next digit to drag down. We don't see one. So you might think, oh, I'll just stop. But you can't because the remainder isn't 0. You have to keep going. Even if I have to keep adding zeros behind the decimal because 105.0 is the same as 105. Now I have another digit and I bring down, I have now 210 down here. I have 210 down here. Now what do I need to multiply by? 28 times something is getting as close to 110 as I can. So let's see, 28 times 7. I'm just guessing here. I've already done 3 times 4. Let's try times 7. 8 times 7, 56. 7 times 2, 14. Then we go up, 15, 16, 17, 18, 19. That's 196. That is as close as I'm going to get to 110. If I go times 8, I know I'm going to blow it. So times 7 goes right here. 7 goes here, and then we multiply, we get 196, subtract. All right, now you can do it many ways. You could go here and borrow, or you could just think about it. If I start from 196 and count up, it's going to be 4 units to get to 200. 197, 198, 199, 200. That's 4 units. Then I get to 200 and count up to 10. That's 10 more units. So that's 14 units. You can subtract. That's fine. But you can also think of things this way and realize that the answer is, you can just kind of sometimes look at it and do it. The answer is 14. So you subtract these, you get 14. After we subtract and get 14, we look for another digit. I don't see another digit, but also my remainder is not 0. So I need to keep going. I'm going to add a second 0 there because I can't stop. The remainder is not 0. And I will drag this 0 down. Now I have 140. So now I ask myself, 28 times something is 140. I don't actually know the answer, but let's try this. 8 times 5 is 40, carry the 4. 2 times 5 is 10, plus 4, that is 14 for 140, so times 5. 28 times 5 is 140, subtract, get 0, and I look for another digit. I don't have another digit, but now my remainder is 0, so now I can stop, finally. And so the answer to this is 3.75. 3.75. So what this means is if I take this amount of something and I divide by this, you could think of $1.05 and I divide by 28 cents. How many times does it go in? It goes 3 whole times, but almost 4 times, but not quite 4 times. Actually, 0.5 is a half. 0.75 is 3/4. So this is 3 3/4. That's the amount it can be divided in. It can't go 4 times. It just goes a little shy of 4 times. In this case, we had to add that second 0 only to continue through the process to get that remainder down here. All right, we have a couple more. Let's continue on. Let's say that we have the problem 0.684. We'll divide that by 0.57. 0.57. What do? we do the same thing we always do. We want to move this decimal 2 positions, so we have to move this decimal 2 positions. So that means we're not going to solve this problem. We'll solve a related problem, which will be 68.4, after I move that decimal, 68.4, divided by 57 on the outside. And then we say, well, we have a decimal here, so the decimal in the answer will be right above it. Now, question. 57, how many times can it go into 68? It can only go once. Times 2 is going to be more than 100, so it can only go once, which will be 57. 8 minus 7 is 1. 6 minus 5 is 1. I've done the subtraction, grabbed the next digit, and now I have 114. 57 times what is 114? I'm not sure, so we go off to the side and say, what is 57 times 2? 7 times 2 is 14. 5 times 2 is 10. One more is 11. That's the 114. So it goes 2 times here. 2 times the 57 is 114. Subtract, and I get a remainder of 0 with no other digits to drag down. So in this case, I know the answer is exactly 1.2. Exactly 1.2. All right, we have just a little bit more, and I think we can squeeze it in here. Hopefully we don't run out of space. We'll see. Let's take a look at the problem. You know what? We'll save a little space, actually, by starting over here. Let's take a look at the problem. 0.18, and we'll divide that by 0.08. Same process as always. We want to move the decimal 2 positions, so then we must move this one also 2 positions. So then, we really don't want to solve this problem. We'll write directly underneath it. We'll solve the related problem, which will be 18, and we'll divide that by 8. 18 divided by 8. So 2 positions makes 18, 2 positions makes 8, and then I'll kind of extend this a little bit, and then we'll remind ourselves that every whole number has a decimal after, so the answer will have a decimal right there. So let's take a look. 8 cannot go into 1, so we consider 18. 8 times 2 is 16, so the 2 goes right there. 8 times 2 is 16. Subtract, we get a number of 2. Now, we don't have any more digits, but we also don't have a remainder of 0, so we really can't stop. We need to then say, well, I'm going to add a 0 after the decimal because it doesn't change the problem at all. 18.0 is the same as 18. Then I drag this guy down, and now I have 20 down here. 8 times 2 is 16. 8 times 3 is 24. So 8 times 2 is 16, and I subtract. Of course, you could borrow and all that. But when you think about it, if you count up from 16, 17, 18, 19, 20, the difference is only 4. So put a 4 down here. So the remainder is 4, and again, I don't have any more digits, so I attempt to add another digit and drag that one down. Now I have a 40 down there. 8 times what is 40? 8 times 5 is 40. So now I have a 40 down here, which then gives me a remainder of 0. So now I have a remainder of 0, no further digits, and so the answer is 2.25. 2.25. That is the final answer, 2.25. All right, we have only one more problem here. We'll work it over here. Let's take a look at the problem 8.64, and we'll divide that by 1.6. So same deal. We have a decimal here. We want to move it 1 position to the right, so we move this one also 1 position to the right. So then we have a related problem that we will solve. 86.4, we'll write it over here, 86.4, and we'll divide that by 1.6. I'm sorry, we move the decimal, so 16. It'll be 16 on the outside. Now, as always, we know we have a decimal here, so we know the decimal in the answer will be there. So question for you. Dividing into 86. 16 times what is 86? I don't actually know the answer, so I'm just going to guess 16 times 5. 6 times 5 is 30, carry the 3. 5 times 1 is 5, plus 3 is 8, and I get an 80. That's as close as I'm going to get to 86, so it goes in 5 times. And I get 80. 86 minus 80 is just 6. And now I, after subtraction, drag the next digit down, 64. 16 times what is 64? Well, it has to be less than times 5 because that was 80. So let's go and try 4. Whoops, 16. I need to put 16 up here, like this. 16 times 4. 6 times 4 is 24. Means you put a 4, carry the 2. 1 times 4 is 4, 5, 6. That's 64. So it has to go 4 times. 16 times 4 is 64. Remainder 0. And I have a remainder of 0. I don't have any more digits to drag down, so I don't have to add any zeros, so I can stop. And so the answer to this problem is 5.4. 5.4. All right, these are long lessons and tedious, but I'm doing so many problems because I really want you to practice with me and get the hang of what you're doing. And so it's almost like breathing, it's almost like talking, it's almost like walking. You just know what to do. And I know I make it look easy sometimes, but please understand I make mistakes all the time. The most important thing is to keep your work as neat as you can. I don't actually like the way I've jumbled the problems in here. That's just because I have these boards, but I would like you to, on your sheet of paper, use a lot of paper and really spread out and really line the columns up, line the decimals up, line the arrows up. All these things are going to make it much, much easier for you. So I'd like to conclude this lesson here. I'd like you to solve all of these. Follow me on to the next lesson. We're still going to be doing dividing decimals, but I'm going to talk to you about what we call in the next lesson a repeating decimal, and what a repeating decimal is, and what to do if you start to find a repeating decimal in the answer to your division problems. Learn anything at mathandscience.com.